Okay, illustrative math, unit 3, lesson 16 is called solving quadratics. So the goal is I can solve quadratic equations by completing the square or by using the quadratic formula. If you don't recall what the word quadratic means your degree is 2. So some examples here of quadratic equations: x squared plus 3x minus 1 equals 0. X squared plus 4 equals 0. Negative 9x squared minus 2x equals 0. These are all quadratic because your highest power is 2. Okay? All right, so the first thing we're going to do is we're going to explore what a perfect square trinomial is. So this expression is equivalent to x plus 4 because what you do is you factor this. You need factors of 16 that add to give you 8. So when you go to set this up, 16, you got 1 times 16, 2 times 8, 4 times 4. I'm going to use the 4 and the 4 because 4 plus 4 would give me 8, which then you could write it like this. Now you could have also factored it with like the box method, which is be something like this. You put the x squared up here, put the 16 here, so x times x will give you x squared. Then we need factors of 16 that these two are going to diagonally here add up to give me that middle term of 8. So I know it would have to be 4 and 4, which would give me 4x, 4x, and if I add these like terms, I would get 8x right there. So as I look at this one, if you want to factor it with the box, you can. X squared there, 25 here. So it'd have to be 5 and 5 if it's going to be like this binomial squared. They'd have to be the same number. So let's see if it works. 5x plus 5x is 10x, so this one is good, yes. Over here, well, 29 wouldn't work because you'd have to, 29 is a prime number. So the only way that you could do 29, the only factors of 29 would be 1 and 29. So then when you add those, you get 30x, so that'd be a no. Let's see here. Let's try this one, 8. Same idea here. 8 is not a perfect square, so there's no way you could have, the only factors of 8 are 1 times 8 and 2 times 4. We don't have the same number, kind of like here where we had the 4 and the 4. So I can clearly see it's not going to work. Or you could have -1 and -8, -2 and -4. So like you could factor this. Like I think that you can get the puzzle to fit together. -4 times -2 equals 8. This is -2x. This is -4x. And when you add those up, you get the -6x. But the problem is what you have is you have x minus 4 times x minus 2. And since these numbers here are different, you can't write it in that form with the binomial squared. So this one would be a no. And then let's go down to the last one. So x squared goes here, the 9 goes here. Well, 9 is a perfect square, so that's nice. I can jump into 3 and 3. 3x plus 3x is 6x. I need to be negative, so if I did -3 times -3, I'd still get 9. -3 times -3 is still 9. And then this would be -3x. So these would add up to the -6. So this one would work. Okay. So what we're doing is we're creating a perfect square trinomial. It's a trinomial that when you factor it, you get a perfect square. So this would be x minus 3 times x minus 3, which we could write as squared. All right, so quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So you might say, what are a, b, and c? A is the coefficient in front of x squared, b is the coefficient in front of x, and c is your constant. So sometimes here what we say is ax squared plus bx plus c equals 0. And they all have to be on the same side. So if you ever had like, if you ever had like a 2x squared plus 6x equals 1, you got to move this 1 over here. Okay, and that way c is negative 1, it's not 1. So yeah. All right, completing the square. So these are your steps. So if you need to pause the video and write this down, go for it. I'll go through it very quickly. So if a is equal to 1, we have to divide both sides of the equation by a. We rewrite the equation so the constant term is alone on one side. So basically you move the c, or c divided by a, if you had to divide, over to the right. You square half of the coefficient of x and add this square to both sides of the equation. That's the step where you're completing the square. And then you factor the resulting trinomial on the left, combine like terms on the right, and then you just square root both sides and use that property to finish it out. So we'll go through a couple of these. All right, so let's look at this first one. Elena and Hans solved this equation different ways. Elena said, first I added 2 to each side. So I guess what Elena wanted to do was she wanted to make this a 9 so that she could get this factored as a perfect square. Because if you look at this here, x squared minus 6x plus 9 would be on the left. And then she said, oh, okay, I could factor that. It's x minus 3 times x minus 3. And then she square rooted both sides, and then added 3 to both sides. So I got x equals 3 plus or minus square root of 2. So I don't know why it says it like that. It should just be a little typo here. This should just be a plus. So 3 plus the square root of 2, and then 3 minus the square root of 2. All right, so Hans is going to jump with the quadratic formula. So a would be 1, b would be negative 6, c would be 7. He plugged all those in for ABC, just basically cut and paste. So here we go. We got to do our order of operations. You square the b. Notice this is 36, not negative 36, because you really, when you plug it in, it's negative 6 squared, which is negative 6 times negative 6, which would give you the positive 36, okay? Negative 4 times 1 times 7, that's going to be negative 28. So what you end up getting is 6 plus or minus the square root of 8 over 2. So then here's where he got that, and then what he did was he split this up. So basically it's kind of like, here, I'll come over here. It's like saying, 6 over 2 plus and minus the square root of 8 over 2, and then 6 over 2 is 3. So those are Hans' answers, okay? So that's what he thinks the answers are: 3 plus square root of 8 over 2, and then 3 minus square root of 8 over 2. Do you agree with either of them? Explain your reasoning. So one thing to do would be to check them with decimals. So I'm going to type in 3 plus square root of 2, and I'm going to see what they are here. So 3 plus the square root of 2 on my calculator is 4.41. 3 minus the square root of 2 is 1.59. And then I'm going to type these in. So 3 plus square root of 8 and then just divide that by 2, and I get the same number here. I get at least the first one, 4.41. 3 minus square root of 8 divided by 2, and I get the same number. So I think that makes me think that they're both right. So why is that? Well, the reason is because he didn't simplify this radical. So we got 3 plus square root of 8 over 2. You have to get perfect square factors out of there. So if you can think of any perfect squares that you could multiply to get 8, you're going to have to rewrite it, square root those perfect squares, and pull them out. So 3 plus square root of 8 is really 4 times 2. 4 is a perfect square. Square root the 4 and pull it out. 3 plus 2 radical 2 over 2, which will now allow me to cancel those. So I get 3 plus the square root of 2. And then if you just put the minus, everything would be the same. So really, I guess I could just tag the minus along there. So now I get the same 2 answers right there. Okay, so they're both right. So just got to check the math. All right, so methods to solve quadratic equations. A little quick review. All right, graphing. Graphing can always be used. The problem is it won't always give you exact answers. So like on Desmos or on your graphing calculator, if I go to graph it, I'm going to look for the x-intercepts. Okay, so you're going to graph, look at x-intercepts. Okay, and again, your calculator or Desmos will give you decimals. If they wanted an exact number, it's not as good. Factoring. Problem is, factoring doesn't always work. So when it does work, it's awesome. But obviously, that's why we have the quadratic formula and completing the squares, because sometimes you have irrational solutions or complex solutions as well. And those are not always factorable. So this says here, if the constant term equals 0 or factors are easily determined. So like if, I had 2x squared plus 4x. So my constant, my c, is 0 here. It's plus 0. So this would be just a very simple greatest common factor. They're both divisible by 2. They both have an x. So there you go. And then you set each factor equal to 0. So 2x equals 0, divide by 2. You get 0. X plus 2 equals 0. You get negative 2. So there's factoring. Completing the square, it works best when b is an even number, and also I would say when a equals 1, because then you don't have to divide. Quadratic formula, but complete the square will always work. Quadratic formula also always works, but other methods might be easier, like you might be able to factor, you might be able to complete the square depending on how it's set up. But this will always work. All right. So I always tell my students, like, definitely be good at quadratic formula because it always works. And, sometimes it might be longer than the shorter ways, but sometimes it's shorter than completing the square. So, like if b is odd, or if a is number other than 1, quadratic formula is a little bit easier. All right. So solve each equation with your method of choice. So I'm going to choose probably the easiest method for each one. I'll try to do a little bit of each. So if you don't have I guess I should have added another method here. Now that I look at it, square roots, I guess, would be another way, and it works sometimes, and that works when b equals 0. Okay, that's when that's going to work. Okay, so an example of that would be, if I have like x squared plus 6, maybe make it minus 16 equals 0. Add 16 to both sides, and then you can square root both sides You get x equals positive and negative. You need two solutions when you have to insert your own square root sign. So like this one, it would be a good candidate for square roots. Square root both sides, plus or minus 10. Square root both sides, plus or minus square root of 38. The only factors of 38 are 2 times 19, and these are both prime. So this is simplified, so you can leave that. If you wanted a decimal, again, a decimal is an approximation. It's not exact, so generally math teachers don't like decimals as much, but I guess I should have put an equals. I should have put a squiggly there. So there you go. There's that. This one I think I could factor. So -5 times -5 would give me 25, and then -5 plus -5 is -10. And if you want to do a box, go ahead, do a box, and you'll get the same answer. Set them equal to 0. So I only have to do it once because it's the same number. So I get x equals 5 for that one. Oh, I forgot my plus or minus here. Sorry. All right. So when I get over here, I think this one does factor. So I'll do a box on this one just to make it a little different than the last one. Put my x squared here, put my 40 here, x into x. 4 times 10 is going to work because 10x plus 4x diagonally adds up to 14x. So remember, it said, I think the direction said to solve. So I'm not done here. I have to set each factor equal to 0. So this step here would be factor, but then if I set each one equal to 0 and make two little equations, I'm going to minus 10 from both sides, minus 4. Those are your answers. All right, so I'm going to go back to my list here. I didn't do any graphing. I think everybody can probably type them in on their graphing calculator or Desmos, find the x-intercepts. I did factoring, I did square roots. I'm going to do the last two here. Do one with the quadratic formula and one with completing the square. So this one here, I'm going to use quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is 1. A is in front of x squared. There's a 1 there. B is 14. C is 39. So I plug everything in. Make sure this number is always positive when you square it, because if you square a negative, it's positive. If you square positive, it's positive. All right, so now it's just a little bit of grinding out the math here. So let's see here. 14 squared is 196. Negative 4 times 1 times 39 is negative 156 over 2. So I get 40. And then here's what I'm going to do. Instead of putting the whole thing over 2, I'm going to split it up. I think it'll make it a little bit easier to reduce. So this is going to be negative 7. I got to think perfect squares, 4 times 10. Take the square root of 4. I pull it out. It's 2. And these cancel. And again, this illustrative math textbook, for whatever reason, it does not simplify radicals. in my opinion, that's not okay. I think that you should always simplify radicals like every other textbook does. So that's how I would write it, but you might see it left like, you might leave it as -7 plus or minus the square root of 40 all over 2 like that. They might leave it like that, but this is better here. All right. Oh, I should have completed the square on that one because this is going to get ugly. This is going to get ugly to complete the square on that one. I don't know why I'm so mad at myself. I'll tell you what, I'm going to do the quadratic formula on this one, and then I'll go back and I'll complete the square for number 5. So x equals +5. So it's -5 because it's negative b. So this is a, this is b, this is c, -11. So -5 squared would be +25. So plug everything in. So this ends up being 25. So I have a negative times positive times a negative. So that is going to be positive. Whoops. So I get plus 132 all over 6. Gives me 157 all over 6. So 157. I don't think there's any perfect squares that go into 157. I'm double checking right now. Yeah, I don't think so. So that would be my final answer here. All right, let me go back to this x squared plus 14x plus 39. Let me extend this. So I'm going to complete the square here. Let me double check it, make sure I got it right. Okay, cool. So first thing I want to do is a is 1, so I don't have to divide by anything. I'm going to move the 39 over to the right. So it's going to be -39. I'm going to complete the square. I'm going to take this 4 divided by 2 and square it. Okay, so 4 divided by 2 squared. Now, normally I just do this in my head, but I'm going to write it out so you got it here. So 4 divided by 2 is 2. 2 squared is 4. Oh, it's a positive 39. Wait. Oh, it's 14. Whoops, I knew there was a mistake. I knew it wasn't working out to the right answer. So, whoops. Copied the problem wrong. Okay. So, sorry about that. So this is going to be 7 squared. It's actually 49. And then this will factor. If you want to factor with the box, do it. I'm just going to do it in my head here. And there we go. Square root both sides. And then I got to get x by itself, so I have to subtract 7 from both sides. And check it out. I get the same answer that I got with the quadratic formula when it's simplified. If you don't simplify it, they might not look the same. All right. So what situations would make you prefer completing the square, and what situations would make you prefer using the quadratic formula? We kind of already hit on that a little bit earlier. So I would say when a equals 1 and b equals an even number, I would complete the square. When I can't factor, or when A is not equal to 1, or when B is odd, I would use quadratic formula. Okay. If one person used one method to get the solutions x equals 5 plus or minus square root of 20, and another person used a different method to get x equals 10 plus or minus 4 radical 5 over 2. How can you determine whether solutions are the same? Well, one thing you could do is you could type them into your calculator to get decimal approximations and see if they are equivalent. Another thing you could do is you could try to simplify them both. Okay, so I'll do the simplifying because it's a little bit harder. If I take the 10, if I split up my denominator, this is going to be 5. So far it's looking good. And then I get here, okay? So now I think it's fully reduced because, oops, hold on. This would be, yeah, because these cancel, sorry. Okay. So then when I go over here, I can see 20 is not fully simplified because it's 4 times 5. Square root the 4, put it on the outside after you take the square root. And now we see that they match up. So your answer would be yes. All right, the other option is type both these in, 5 plus square root of 20, and then do 5 minus square root of 20, see what that decimal is, and then do this. And those decimals should match up because we got them to be equal. All right, so our goal, I can solve quadratic equations by completing the square or by using the quadratic formula. I think that's a yes. All right, so this one I'm going to factor. And then if I just set one of them equal to 0, I get x equals -2. Okay. So I tell you what, since our goal was to use the quadratic formula though and completing the square, I'm going to do completing the square. Move the 4 over to the right. I put a couple blanks. I take this number in front of x. I add that divided by 2 squared to both sides. So 4 divided by 2 is 2. 2 squared is 4. So I get 0, which is kind of funny because it takes us back to exactly where we were. Which you would then factor this. And then square root both sides. We get x plus 2 equals, I'm not going to put a plus or minus in front of 0. And we get to the same number. Now this time it ended up being a lot more work than just factoring, but we still got there. This one, I'm going to go with the quadratic formula here. Now here's my suggestion. If x squared is negative, I like to move it over to the right. So if I add 5x squared minus 7x minus 2, if I do that to both sides, I can now put the 0 on the right, and then it's positive for the a. So 5 is a, negative 7 is b, negative 2 is c. So negative b, negative 7, Square root of b squared. Negative 7 squared would be positive 49 minus 4 times 5 times negative 2. 4ac all over 2a. So I get 7 plus or minus square root of 49. So this is going to be a positive because I have two negative signs. Negative 4 times 5 times negative 2. So this is, whoops. So this is plus 40 all over 10. And I'm going to, that's a 10, that was 6. 89. I don't think there's any perfect squares that go into 89. If you weren't sure, you could just take 89 on your calculator and divide by 4, divide by 9. Keep going through all your perfect squares. And if it goes in evenly, then you know you can square root the perfect square and pull it out. So yeah, I think that's the final answer. You might see it split up like this, 7 over 10. Either way are fine. All right. Thank you for watching, and I hope you enjoyed this video.